Alright, so we're going to talk about work in this video. Not in the sense of like homework or cleaning up your room or trimming the lawn or something like that, or maybe doing construction like these guys right here, right? We're not talking about that kind of work, although a lot of that is work in the physics definition too. But we're going to talk about the physics sense of the word work. Okay, so here goes. Work, we'll just go ahead and get the definition. Work is equal to the force that is applied to an object multiplied by the distance traveled in the direction of that force. Now, oftentimes, what we're going to talk about is work done against gravity. So against the force of gravity, right? So basically it would be the work done in lifting some weight upwards some distance. Now, it's important to note in the direction of the force, okay? So you don't count sideways motion if you're talking about working against the force of gravity, okay? So the force applied is upwards in this case. It's an upward force, right? Because gravity works downwards. So basically, if what we're trying to do is counteract the force of gravity, then what we have to do is apply an upward force, as you see there, upward force, right? Gravity acts downwards, so we counteract that by going upwards. So the only movement that counts, if you're talking about work done against gravity, the only movement that counts is upward force, because that is the force that you're applying to the object in order to overcome gravity. All right? Sorry, that was a little bit of a long explanation. But see how this guy's kind of moving sideways and up? The only part that actually counts as work is the part of moving the box from the floor upwards. The sideways motion doesn't count. All right, it's kind of weird, but that's the way it works. All right. Cool. All right, so here we're looking at the equation form of this definition. So work is equal to force applied times the distance traveled in the direction of the force. We can summarize that with this. Work is equal to force times distance. Okay, but remember, it's distance in the direction of the force. So if we're talking about weight again, the only distance we're concerned with is how high, the change in vertical height, not the change in sideways motion. That doesn't count for calculating the work. All right, so let's take, for example, this guy here. Maybe he's moving. His wife is helping him, being very helpful and loading him up with all kinds of boxes. So, I don't know, he might not make it very far. But let's just suppose that he's taking these boxes and they started out on the floor. Right, so they started out here on the floor, and then we're going to lift them up onto this counter over here, right? So in that case, the work done would be the force applied, in other words, the weight of the boxes, add those all up, and then multiply by the distance between the floor and the countertop. All right, so that distance, D, all right, that distance times the weight of the boxes. All right, which is the force that you're applying. Okie dokie. Nice example there. So, question would be, how can you do more work? Well, how can you do more work? Well, there's two ways. You could apply the same force over a longer distance. So if you lift those boxes higher, maybe way up onto a shelf, all right, that would be more work. Or you can apply more force. So how do you get more force? Well, you could pile on more boxes or get heavier boxes, right? So if you lift a heavier box up onto this counter, heavier box up there, that's more work than if you lift a light box up there, because it takes more force to lift a heavy box. A heavy box has more weight, and as you recall, weight is a force. So you're going to apply basically an equal force to the weight, right, in an upwards direction. If you're going to try to lift a box, you're going to have to apply roughly the same amount of force as the amount of weight that the box has. Okay, so that amount of force lifting it up onto the counter. So there you go. Okay, time for an example. So let's take this sample question. A worker at a factory is lifting boxes onto a conveyor belt. Each box is identical to the other boxes, and each box weighs 100 newtons, which is a mass of 10 kilograms. Okay, the conveyor belt is 1 meter off the ground. How much work is required to lift each box? So this is a really straightforward problem. If you recall the definition of work is equal to force times distance applied in the direction of the force. So in this case, we'll do this in red. Force is 100 newtons for each box, 100 newtons, and the distance is 1 meter. So if we go back over here, work is equal to force times distance. So force 100 newtons times the distance, which is 1 meter. And you can see right away, we're going to end up with an answer of 100. Your question is, what are the units? Well, work is actually measured in the same units as energy, so it's called joules. So what we've done in each box, lifting each box, is going to require 100 joules of energy, basically. So we're doing 100 joules of work. All right? Cool. That's it for this video. Hope that was helpful.